Hello again to another Aga Color React, and today we will be watching the big problem that happened after we nuked space. I didn't even realize we did nuke space, and it's from Astrum, so it's a good outer space channel, so let's just watch.
In 1945, the US dropped 2 nuclear bombs on Japan, which changed the course of the Second World War. 17 years later, another nuclear explosion changed the course of the Cold War. Except this explosion happened in space. The explosion of Starfish Prime was a pivotal moment in the space race that shaped our perception of nuclear warfare. The story is crucial for understanding how we arrived at today's space policies, and why it's imperative no nation is allowed to place nuclear weapons in orbit. I'm Alex McColgan, and you're watching Astrum. Join me today as we discuss what Starfish Prime was, the critical lessons it taught us, and why we don't send nukes into space anymore. In the early 1960s, the US launched a series of 5 nuclear tests in outer space. Known as Operation Fishbowl, their aim was both military and scientific. The military wanted to study the effectiveness of nukes as anti-ballistic missile measures, and how a space-based blast might interfere with electronics, communication, and military operations on the ground. Scientists wanted to know how a space explosion would impact the Earth's magnetosphere.
Where did they... I just have exploded in my, where did they detonate it? Like, over what part of the Earth, and how far from Earth? I guess we're gonna get those answers anyway.
And what kind of electromagnetic pulse it would generate. Starfish Prime was the first blast of the bunch. On July 9th, 1962, almost 1,500 kilometers west-southwest of Hawaii, a Thor rocket carrying a 1.4 megaton thermonuclear warhead launched
big
for the stars. That's 500 times more powerful than the one that destroyed Hiroshima. 27
times.
smaller missiles loaded with scientific instruments were fired up alongside it to gather data on the blast and its subsequent effects. As the Thor rocket raced upwards, the nuke finally exploded at an altitude of 400 kilometers, about the height of the International Space Station today. And what a sight it must have been. Ionized particles from the explosion collided with molecules in the Earth's atmosphere, creating widespread auroras visible across the Pacific, even as far away as New Zealand. Just below the explosion, the cloudy night sky of Honolulu was lit up for a full 6 minutes. It was as though another sun had emerged at 11 p.m. Radio stations wavered, a siren was set off, and streetlights across Hawaii were even knocked out. The historical context of Starfish Prime is important. The early 1960s marked one of the most tense periods of the Cold War, with the US and the Soviet Union locked in a fierce struggle for global dominance. Both superpowers sought to outdo each other in military strength, political influence, and technological prowess. The space race became a key battleground, and by 1961, the Soviets had the upper hand. They successfully sent the first rocket into space in 1957, and 4 years later, Yuri Gagarin became the first human in space. Pressure on the US intensified as it began to fear the Soviets might develop space-based military power before them. With tensions escalating after incidents like the Berlin Crisis, both nations saw the militarization of space as a way to gain a strategic advantage in the Cold War. This sparked a race to develop nuclear weapons, missile defense systems, and other technology that could be deployed in space. Military planners were concerned about how these nuclear weapons could be used in space and what effects the detonation of such weapons might have on global military strategy. More specifically, they were worried about the electromagnetic pulse, or EMP, that would follow such an explosion. An electromagnetic pulse is a burst of electromagnetic radiation produced by a nuclear explosion, especially high altitude or space-based detonations. This pulse can generate powerful electric and magnetic fields capable of disabling electrical circuits, disrupting communications and causing widespread damage to infrastructure like power grids, satellites, and radio systems. Back in the early 1960s, scientists knew that nuclear blasts produced EMPs, but the full scale and potential damage of such EMPs was not well understood. Operation Fishbowl was a chance to study these effects more closely. Launched from Johnston Atoll, Operation Fishbowl was a series of 5 high-altitude tests conducted by the US. 3 months after Starfish Prime, the US launched the remaining 4 tests in a span of just 2 weeks. The second test, eerily named Checkmate, launched on October 20th, 1962. The 20-kiloton bomb, similar in size to the one dropped on Hiroshima, detonated at an altitude of only 147 kilometers. This was rapidly followed by a bluegill.
Sorry for the face I made there. For some reason I thought that the 20 kiloton is bigger than the 1.4 megaton that they had there. But megaton is always bigger than the kiloton, so obviously, yeah.
Triple Prime on the 26th of October, Kingfish on November 1st, and finally Tightrope on the 4th of November 1962. Bluegill Triple Prime and Tightrope were both smaller explosions that detonated at 48 and 23 kilometer altitudes respectively.
Well, I guess what's the difference, isn't it? Like, they already dropped bombs on actual populated areas of Japan in 1945. They were making then, not only Americans, but Russians and French and British were doing tests on Pacific Ocean and Indian Ocean. So it wasn't even like high up in the air, it was just on the ocean level and stuff like that, just dropping bombs on the random, not random, obviously they choose for reasons, but some islands like Hawaii Islands, isn't it? Not Hawaii, Bikini Islands, or is it Atoll? Bikini Atoll, I think. Anyway, so they were testing it there as well. So I don't think that now that, like, hearing that it wasn't that high, because comparing to the first one when it was 400 kilometers up high, 20 kilometers doesn't sound that much. But then if you compare that to dropping bomb on the actual Earth, like an island or something like that, it's nothing.
Triple Prime was aimed at understanding lower atmospheric effects of such explosions in the mesosphere, while Tightrope was conducted as an anti-missile test in the stratosphere.
Oh.
NASA defined space as starting at an altitude of 80 kilometers, so I suppose these nuke tests weren't strictly carried out in space. Kingfish was. Its 0.41 megatons detonated 95 kilometers above sea level, but these paled in comparison to the explosion of Starfish Prime. The immediate impact of Starfish Prime struck awe into those who saw it. Auroras stretching thousands of miles, a fireball over Hawaii, all happening in...
Can you imagine reactions of people that they didn't have, let's say, access or they didn't see? Like, they obviously made something that they're gonna be testing it and things, so people kind of knew, like some people, but not everyone were reading newspapers or had access to TV or radio. I wonder if they actually were doing some kind of TV or radio announcements about that there could be something like that. I would be scared like nothing if I see something like that in the middle of the night.
Total silence. Unlike explosions on the ground, when a nuclear detonation happens in space, you can't feel a shock wave or hear a sound. There is no mushroom cloud or double flash. There's just a bright ball of plasma, which changes colors like a lava lamp as charged particles are pushed down into the atmosphere by Earth's magnetic field. These colorful auroras give high-altitude nuclear explosions the nickname rainbow bombs. But the lasting effects of such an explosion are far from sunshine and rainbows. Starfish Prime impacted the Earth in 2 big ways.
Meaning what? Come on, Alex, just say it! Never mind, there's an ad. For some... What is this for? Some dungeon entrances in Top Heroes are super hard to find. Top Heroes game, isn't it? Yeah, so, I was just talking, so I don't really have much to add now. I just want to know what's going on and what was those waves, so I'm gonna have to wait for the rest of the video, I guess. So, yeah, I'll see you in a moment there. And, I'm sorry if I keep looking on the side, but my computer is kind of... I'm not sure what's going on. I just have to monitor the CPU on it, so yeah, it's kind of high today. So I'll see you in a sec. Bye. Hello again, and let's just jump into it because, well, we need to have something to watch, and I had nothing else to add. So. Oh.
58. The US space mission Explorer 1 discovered that the Earth is surrounded by two donut-shaped regions of intense radiation. Today, we call them Van Allen belts, after the scientist who discovered them. These belts are made up of charged particles, mainly protons and electrons trapped by Earth's magnetic field. They act as a protective shell against harmful solar radiation and cosmic rays, capturing high-energy particles from the sun's solar wind. The Starfish Prime explosion released such a quantity of charged particles into Earth's magnetosphere that it altered the composition and intensity of the natural Van Allen belts, and even created artificial radiation belts that were stronger and longer than the originals. These persisted for up to a decade, shortening the lifespans of several satellite systems and interfered with telecommunications. They destroyed two early satellites, Ariel 1, Britain's first satellite, and the first TV broadcasting satellite, Telstar 1. But that's not all Starfish Prime did. Remember the electromagnetic pulses I told you about earlier? Scientists knew the blast would emit them, but no one could have guessed just how intense they would be. Nuclear detonations emit gamma rays in all directions, known as a Compton current. When they interact with Earth's atmosphere, they ionize air molecules and liberate high-energy electrons. Since Starfish Prime detonated at an altitude of 400 kilometers, these gamma rays collided with atoms in the upper atmosphere, creating a cascade of free electrons. Accelerated by Earth's magnetic field, these electrons produced a rapid and intense oscillation of electromagnetic fields. At high altitudes where the atmosphere is thinner, this pulse is able to spread much further than it would in a low altitude explosion. The EMP from Starfish Prime spanned thousands of kilometers, damaging electrical systems far from the detonation site. Almost 1,500 kilometers away in Hawaii, streetlights went out, telephone lines were disrupted, and radio communications were affected, showing how vulnerable civilian infrastructure is to such an event. Starfish Prime made the world realize just how destructive an EMP can be. It revealed how vulnerable electrical grids, communications, and satellites would be to a nuclear EMP attack. If added to the strategic arsenal, it would give any military the capacity to cripple enemy infrastructure without direct contact or bloodshed. Starfish Prime also released an isotope called cadmium-109 on explosion, which was used to track the fallout and measure resulting contamination. While ground tests normally leave behind a characteristic localized fallout pattern, the effects of space testing were global. New Zealand rainwater was found to be contaminated with cadmium-109, which a 1966 Nature article attributed to Starfish Prime.
That's not very good to hear something like that. I'm not sure what to say about it. Obviously, it wasn't a good thing, but I want to believe that they... I can't say that I want to believe that they haven't seen that coming, but they must have think that there would be some kind of fallout, some kind of repercussions to it as well. And yeah, okay, let's just okay, I'm supposed to play the ad. I keep forgetting to play it. So let's just try, and I'll be back in a moment, and I'm gonna keep watching what happened there. So bye. Okay, I'm back, and I'm gonna be jumping straight into it because well, there's no time to waste time. Yeah, that wasn't right. Hello, hello, YouTube, wake up, or computer, wake up. Oh yeah, there's something going on here.
These kinds of reports raised significant environmental concerns about the long-term impact of space-based detonations on Earth's atmosphere and environment. And imagine, Starfish Prime wasn't even the biggest bomb the US had ever detonated on the edge of space. That prize goes to Teak from Operation Hardtack in 1958. At 3.88 megatons, it was over twice as big as Starfish Prime and detonated at an altitude of 76.8 kilometers. It turned night into day and cut many trans-Pacific high-frequency communication circuits. According to the Nuclear Defense Agency report on Operation Hardtack, it destroyed the ability of the normally ionized layers of the upper atmosphere to bend radio waves back to the Earth. The Soviets were also busy testing high-altitude nuclear explosions, detonating 7 space bombs over Kazakhstan between 1961 and 1962. Known as Project K, their aims and effects were much the same as the US tests. Detonated at altitudes ranging between 40 and 300 kilometers, none were quite as big as the American bombs. They ranged in size from 1.2 to 300 kilotons, about 5 times smaller than Starfish Prime. On October 22, 1962, a 300 kiloton missile warhead known as Test 184 detonated at an altitude of 290 kilometers. The EMPs generated started a fire that burned down the Karaganda power plant and blew over 1,000 kilometers of shallow buried power cables between Tselinograd and Alma-Ata. These learnings had serious Cold War implications, highlighting the need for international agreements to prevent nuclear testing in space. The unforeseen consequences of Starfish Prime eventually led both superpowers to reconsider space-based nuclear strategies. 1 year later, in 1963, the Limited Nuclear Test Ban Treaty was signed by the US, UK, and USSR. It prohibited nuclear weapon tests in the atmosphere, outer space, and underwater to reduce radioactive fallout and curb environmental contamination. The Outer Space Treaty followed in 1967, which banned the placement of nuclear weapons or other weapons of mass destruction in outer space. It also forbade nuclear explosions in space or on celestial bodies, ensuring space remains a domain for peaceful exploration and not military confrontation.
Hopefully that's gonna work.
Our modern world relies heavily on space-based infrastructure. Satellites underpin global navigation, communications, the internet, GPS, and more. A nuclear explosion in space would spell chaos for us below.
True.
Global commerce and trade routes would crash and grind to a halt. Our electronics and power grids would be fried, bringing critical services to their knees. Hospital equipment would stop working, millions of tons of food would go to waste without proper preservation, and financial markets would collapse. The effects of a nuclear EMP would be far more devastating today than they were in the 1960s, as our vital global systems and everyday lives rely much more on electronics than they did back then. We've established that various international treaties are in place today to ban further nuclear space explosions. But could such catastrophic events caused by an EMP still occur in some form today?
I say so.
In 1859, the world's largest ever recorded geomagnetic storm, the Carrington event, caused some pretty wacky things to happen. Northern lights were reported as far south as Cuba and Honolulu.
Whoa!
And were so bright, people in the north of the US could read newspapers just by the light of the aurora. It threw sparks from telegraph
Crazy.
equipment across the US, some strong enough to set fires. If a CME of similar magnitude were to occur in our direction, it could hit us with very similar effects like Starfish Prime. Fortunately, the chances of that happening are very slim. The more likely risk is a geopolitical one. Earlier this year, Russia made headlines for vetoing a UN resolution against putting nuclear weapons in space. Several news outlets have since speculated that Russia is planning on placing a nuclear warhead in low Earth orbit. According to John Plum, an assistant defense secretary for US space policy, Russia is developing a
I would just like to say this video was published on the 6th December 2024, so a while ago, you know.
concerning anti-satellite capability. A new satellite carrying a nuclear device that Russia is developing. This capability could pose a threat to all satellites operated by countries and companies around the globe, as well as to vital communications, scientific, meteorological, agricultural, commercial, and national security services we all depend on. This is in direct violation of the 1967 Outer Space Treaty, which, though still in effect, sadly doesn't come with any formal enforcement mechanisms.
True.
These international agreements exist to prevent space from becoming a battleground for nuclear weapons. They must be respected to ensure all of our safety and well-being. As space becomes increasingly important for modern life, the lessons of the past are more relevant than ever.
Another ad?
You know what's wild?
Damn, guys! It's a lot of ads for fingers are just almost gone as well. I really don't know what to say or how to feel about it. Because obviously it's not something that we want to hear about, and the fact that, I don't know, did I miss the whole thing about Russia thinking about putting nukes up into space and the orbit? Me, I think I did, or it's just kind of like went over my head with the other bullshit that was going on around the world at the same time. You know, like those famous elections in November. Definitely not something I want to hear about. That someone who I'm rather antagonistic towards from just the fact of me being who I am as a national of Polish Republic of Poland. Historically speaking, our nations are not in the great relations. So yeah, I don't want to hear that, but I don't want to hear America doing the same thing either, or China, or India, or anyone. I don't want anyone to have nukes up in the space. And in general, I would rather there would be no nukes in general, but well, this is supposedly preventive stuff, is it? So yeah. And yeah, there's only like a few seconds left, but I'll be back in a moment. Not seconds, it's longer than seconds, but yeah, I see you soon. Bye. Okay, we are back and we can jump in, and let me just remember to actually put the view of the video for you as well.
Starfish Prime showed us the devastating reality of weaponizing space. The electromagnetic pulses crippled infrastructure, unleashing waves of radiation that lingered in our atmosphere for years, destroying satellites and contaminating the space around our planet. This experiment was a turning point. From it emerged one of the most important lessons of the nuclear and space age. Space could be weaponized in ways that affect not just individual nations, but all of humanity.
Yep.
This is why international treaties now ban the use of nuclear weapons in space. These agreements are promises to future generations, pledges that space will remain a place for discovery and peace, not for conflict and destruction. This is why responsible, peaceful space exploration is so important, so we can continue to unravel the mysteries of the universe and make discoveries that inspire and unite humanity without the lingering shadow of total annihilation.
No, not
Thanks
the
for watching.
spoilers for all mankind.
If you like this video, you may like my others about space history. Have you heard of the time Zambia entered the space race and tried to go to Mars? Click here to watch it next.
Okay.
Thanks for watching. Making this video required some long-term planning and work.
Okay. So yeah, I kind of said what I had to say about the fact that I'm not very happy about anyone having any nukes out in the space. So that's my take on it. And I'm just thinking, back then when they were testing it, there wasn't that many satellites out there. And he said just 2 of them were destroyed. And now with the stage when there's thousands upon thousands of satellites, isn't it? I could see. So how many satellites orbit Earth? So the AI overview gives me the answer that as of 2023, approximately 6,718 operational satellites were orbiting Earth. This number includes satellites owned by various countries and organizations, with the United States owning the most. Additionally, a significant amount of space debris, including inactive satellites and rocket stages, is also present in Earth's orbit. So yeah, that's a lot, thousands of stuff like that. So yeah. So if something would happen, that there would be a nuke exploding in the orbit, or because that's at least it's preventable from our point of view, or there was another massive solar flare like that in 19th century, I'm not going to use, but we're just in very big trouble. Yeah, I can't imagine how would that look if a lot of, even just part of the satellites be destroyed. What chaos would actually ensue on Earth. Yeah, I'm kind of, it's scary if you think about it. Thank you very much for watching, and I see you tomorrow. Bye.